Hello everyone, welcome again to our generative AI from scratch series. So in this last video, we have covered the basic of the generative AI and the basic flow. Now in this video, we'll be covering the transformers and large language models. So why transformers? Uh, like before 2017 or 16, most of the AI models that worked with text, they've been using the neural networks that we have discussed in our previous videos, and they were using the long short-term memory networks. So these network process text word by word in order, like reading a sentence one letter at a time. So they were slow and they were very hard to train and bad in remembering the long sentences. Now then came 2017 paper from Google. So that introduced transformer architecture and it changed the AI models. It was faster, parallel, and more powerful than the previous models. The core idea is attention mechanism. So the key concept behind transformer is attention, especially self-attention. So if we understand it with an example, like the cat sat on the mat. When the model reads cat, it learns to pay attention to words similar to it, like sat, mat, which give it meaning, and less attention to those unrelated words. Okay, so this allows you to understand the context, not just the other words that are irrelevant. Okay, and if we change this to another example, like the cat after chasing the mouse sat on mat. So now in this, the transformer still knows cat sat, even the distance is very long between them. Like earlier the cat sat on mat, the distance was very short between words, but now the distance from cat to sat is huge. But still the transformer still remember that cat sat. So to conclude, transformers remember all relationships using attention weight. They use self-attention mechanism. So now let's understand the transformer basic architecture, how it looks. So it mainly consists of two parts, encoder and decoder. Encoder reads and understands the input text that you provided, and decoder just generate the desired output. And what internally this model is doing? So we have the first input sentence and then input sentence to embedding, then self-attention, then feed forward, and then encoder, which is the final output. So how it works? So the first input sentence to embedding layer, what happens is your word get converted into numbers that model actually understand. And then from embeddings to self-attention layer, where the core brain of transformer exists, okay, and it lets every word look at each other and understand them by using the self-attention concept. Okay, and then comes the feed forward network part. Okay, after attention, providing the attention to the figures, then it provides attention to the relationship. Like it's kind of a small neural network there that process all of these, and then the final output that AI produce with the smart context-based representation. And if we try to understand how this attention actually works internally, so let's understand with a simple example. Like I've provided it an array of words. Like basically I've provided a sentence, I love AI. So basically it will split into individual words, I love AI. Okay, and then the model will convert it into vectors. Okay, then it will calculate the query key value. Okay, now then it internally use a formula. You do not need to be concerned about that formula. That's the transformer internal processing, but I'm just telling you for the clarity. Okay, then when we have the query key value, then the model computes the attention score with query and key, and then it provide those values, that attention score, to the final formula which is written here, and then it conclude the attention output. Then comes the feed forward plus normalization, and as I've already told you, after attention each layer has a small feed forward neural network. Okay, so I've already discussed about the neural networks in our previous videos. go and check out if you have any doubt regarding this, and then come to this video. So after attention layer, we have this small feed neural network, okay, for deep kind of processing, for deeper feature extraction. And then we have the normalization layer for stable training. So this is about a single layer. If you stack and if you bundle multiple different kind of similar layers to one another as a bundle, so what it will create? It will create for you a deep model like GPT or BERT. What are LLMs? So LLMs are just transformer. Those are scaled up with billions of parameters, and they are trained with massive text data sets. Okay, so we have different models that I will also show you in the coming examples. Like we'll use GPT-2, we'll use BERT. Okay, so these are some of the transformer basically that we have, and they create the LLMs, the large language model. Okay, now let me take you to my VS Code and I will show you a basic LLM example. How we use this transformers like GPT-2, I'll be using that, and how we can use that transformer for text generation. Okay, so we are inside our VS Code. I've just created a basic example. Okay, I've created a file here, LLM basic example. Okay, so let me generate our code. So from transformers, we will be importing the pipeline. Sorry. Okay, and then we'll create our LLM with this pipeline, and we'll be passing what we want to do. We want to do the text generation here. We'll be using that, and then we'll pass our model. GPT-2. Okay, now once we have the LLM there, our model is ready, then we'll provide a prompt. Okay, so we'll provide our prompt as in the future artificial intelligence will, and then we'll leave it. We'll leave for the model to complete it. We want to see if model can complete it and how advanced our model is, and what text it will write for us. So you will see that how advanced these models are. And this is just a simple text generation model, a very simple basic model. We have many other models as well. Sorry. I will explain you, just a minute. Result 0, and then we'll get the generated output out of it. Okay, so as I've told you, let me save it. We are just importing a pipeline from the transformer. Okay, and in this pipeline we are providing it that we want to do the text generation. We are providing the model, on which model we want to do it, and then a prompt, and then we are executing it. Sorry. Okay, we are executing it by calling our model and providing prompt to it, the max length, how much lengthy we want the text generation to be, and the temperature, like how creative we want our model to be. Okay, once it is done the execution, it will store the result in the result variable, and then it will provide us an array on 0 index. It will provide us the generated text. So let me execute it and I will show you. So now the code is ready. So let me go ahead and execute it, and let me show you how creative this model is and how it will complete the sentence for us. So I will execute my file. So it will take some time. It will follow some step. It will basically take out that model for us. Okay, and then it will take our prompt. It will tokenize it, and then it will set all parameters, and then it will generate our output. So as you can see, it just provided us the generated text. So we have just provided it this much. In future, artificial intelligence will, okay, and then this much text it generated it. Now you will notice this text has artificial intelligence will no longer be a problem for the US government or government policy. Now let me just change the temperature. Let me make it a little more creative, and let me execute this command again. Let me clear it first. Sorry. Let me clear this first, and you will notice the change in the output. So you can play with the models like this. You can change max length, prompt, temperature, and other parameters as well, and then you will notice it can change the output accordingly. So now you can see when I made it 1.0, what it does in the future, artificial intelligence will be able to better serve all of us regardless of race or gender, will become the future of all human beings. Okay, so that's how it changed the output. Okay, so I hope this is pretty much clear to you about the transformers and the large language models. We'll be learning more about them in the coming videos. So thanks for watching, and see you in the next video. Bye bye.